Today we are unpacking a pivotal moment in the history of American technology. We are looking at the Genesis mission, officially launched by the Department of Energy on November 24th, 2025. This initiative is being described by officials as nothing less than a Manhattan Project for AI. But unlike the projects of the past, the goal here isn't weapons development. It is to double the productivity and impact of American science and engineering in just 10 years. This is a deep dive into how the U.S. plans to integrate artificial intelligence into every single facet of national research. To understand the mission, you have to understand the problem. We are currently shifting from the era of AI for chatting to AI for physical discovery. The image on the left represents the limit of human cognition. In complex fields like materials science or drug discovery, there are billions of possible molecular combinations, far too many for any team of human researchers to test manually. The Genesis mission represents the leap. It moves us toward agentic AI, tools that don't just process text, but can manage complex workflows and control instruments. This allows us to navigate that complexity and test hypotheses at a scale and speed that was previously physically impossible. Powering this leap is a massive new infrastructure called the American Science and Security Platform, or ASSP. This isn't just a piece of software. It is a unified ecosystem connecting all 17 of the nation's national laboratories. The beating heart of this system is Solstice, a flagship supercomputer hosted at Argonne National Laboratory. Solstice is a beast of a machine powered by 100,000 NVIDIA GPUs and hosted on Oracle Cloud. It is designed for closed-loop research, linking supercomputers directly to autonomous robotic laboratories that can design experiments, run them, analyze the data, and refine their own hypotheses in days rather than years. The mission is strictly organized around three pillars of strategic dominance. First is energy dominance. This involves accelerating the stabilization of nuclear fusion, designing next-generation modular fission reactors, and managing a smarter national power grid. Second is national security. The focus here is securing supply chains for critical minerals like lithium and cobalt, and ensuring the safety of the nuclear stockpile without the need for physical testing. Finally, we have discovery science. This pillar explores quantum algorithms and uses tools like AlphaGenome to map the mysterious non-coding parts of the human DNA sequence. Geographically, the mission turns the national labs into a single, unified discovery engine, but the brain of the operation resides in the computing powerhouses. Argonne National Laboratory is the lead here, hosting the Solstice system we just mentioned and leading the ModCon project to build self-improving AI co-scientists. Then there is Oak Ridge National Laboratory. They manage the American Science Cloud, which acts as the secure connective tissue, allowing all 17 labs to share data. Oak Ridge is also preparing for the future, with the deployment of the Lux AI cluster in 2026 and the massive Discovery supercomputer slated for 2028. While Argonne and Oak Ridge handle the data, the security triad focuses on defense and stewardship. Los Alamos is taking a lead role in safe AI, partnering directly with OpenAI to test frontier models on the Venado supercomputer for tasks like biosecurity and scientific reasoning. Lawrence Livermore is utilizing AI to accelerate inertial confinement fusion, building on their recent breakthroughs in ignition. Meanwhile, Sandia National Laboratories is focusing on hardware, developing neuromorphic chips, processors inspired by the human brain, to create energy-efficient AI workflows for deterrence. What truly sets the Genesis mission apart is its architecture. Historically, government projects were insular and secretive. This mission, however, relies on a coalition of 24 private partners. It is a public-private cloud model where the government provides the massive proprietary data sets and the physical facilities, while Private industry provides the raw compute power and the intelligence layers. This coalition includes heavy hitters like Microsoft, AWS, Google, and NVIDIA, transforming vendor contracts into deeply integrated research collaborations. Let's get specific about who is doing what in this ecosystem. NVIDIA and Oracle are providing the computing backbone at Argonne with those 100,000 GPUs. OpenAI is working with Los Alamos to deploy their O-series reasoning models, moving beyond simple chat to complex physics problem-solving. Google DeepMind is providing AI co-scientist tools like AlphaGenome and AlphaEvolve to all 17 labs. Anthropic is focused on safety, using their Claude models to classify nuclear risks with 96% accuracy. And finally, AMD is powering specialized clusters at Oak Ridge to tackle fusion research. The Department of Energy isn't waiting years to see results. They have identified lighthouse problems, high-stakes scientific challenges selected to prove the platform works by late 2026. The DOE is mandated to finalize a list of 20 of these national challenges by January 2026. These are the problems that were previously considered computationally impossible, which the mission aims to solve first to demonstrate initial operating capability. Let's look at the top contenders. The first lighthouse problem is nuclear fusion. The specific challenge here is plasma disruption. When researchers try to create a star on Earth, the superheated plasma can become unstable and damage the machine. The solution involves building a fusion digital twin. Lead researchers at Lawrence Livermore and Princeton are partnering with NVIDIA and AMD to build a real-time AI that acts as an autopilot. It predicts instabilities in milliseconds and adjusts the reactor instantly to keep the plasma stable. Next, we have materials science. Historically, finding a new material for a battery or a magnet took 10 to 20 years of trial and error. The Genesis mission is deploying a closed-loop system to change that. In this scenario, AI designs a molecular structure, and robots at Ames National Lab physically build it. Sensors then feed the results back to the AI instantly. The goal for 2026 is to discover and validate a new magnet or battery chemistry that reduces the United States' reliance on foreign supply chains for critical minerals. The mission also targets our energy infrastructure. On the regulatory side, Idaho National Lab is using AI trained on Nuclear Regulatory Commission data to cut the paperwork time for new small modular reactors from 5 years to under 18 months. Simultaneously, we are looking at grid auto repair. The National Renewable Energy Laboratory, or NREL, is deploying an AI microgrid coordinator. This system is designed to simulate millions of what-if scenarios and reroute power during a cyber attack or storm in under 30 seconds, preventing cascading blackouts. The timeline for this mission is incredibly aggressive. It is a sprint mandated by executive order. By January 2026, the 20 priority challenges must be finalized. By May 2026, the labs will launch the first scientific foundation models, trained on decades of proprietary federal research data. And by August 2026, just 270 days into the mission, they must demonstrate initial operating capability. This means they have to prove the AI has effectively solved a major problem in fusion or materials science that was unsolved just 2 years prior. Ultimately, the goal isn't just speed. It is a fundamental change in methodology. We are moving toward AI co-scientists, agentic tools that can use software, control instruments, and manage workflows autonomously. By cleaning and pre-processing data ranging from particle physics to molecular biology, the DOE aims to move past the limits of human cognition. This unlocks solutions in clean energy and medicine that were previously out of reach simply because we couldn't process the data fast enough. This is the Genesis mission. It is a unified AI-driven engine designed to prove what is possible when you combine the scale of the U.S. National Laboratory System with the speed of private industry AI. Thanks for watching. Let us know in the comments which of these lighthouse problems you think will be solved first: fusion, the grid, or materials. See you in the next video.